Hello and welcome to Merlin Tuition. Today we are looking at the reverse chain rule. Specifically, we are looking at integrals in the form of f dash of x over f of x to the power of n, always integrated with respect to x. Okay, I have got 3 examples on the screen right now. If you'd like to pause this video and have a go at those examples, you can. I'll give you a moment and then we'll move on. Okay, so moving on. Our first integral here, integral of 2x over x squared minus 3 dx. Now, if you've learnt this before, you will have seen a few different ways of dealing with integration using our reverse chain rule. I'm going to do this properly, and then I'm going to show you how the pattern works. So, the very first thing we're going to do is we're going to see this x squared minus 3 is actually, we could write this as 2x times x squared minus 3 to minus 1. Okay, so this is a function, x squared minus 3, right, which is inside the function to the minus 1. In other words, this on the bottom, x squared minus 3, is a function. That we're identifying as this, f of x. So what we're going to do is we're going to use a substitution to deal with this, much like we have in differentiation. We say that u is x squared minus 3, which means we are now trying to integrate 2x, u, which was x squared minus 3, to the minus 1 dx. Now, we don't want to be trying to integrate u with respect to x, we want to be integrating with respect to u. So we're going to have to use some chain rule. Integrating with respect to dx is the same as timesing dx by du and then integrating with respect to u. And so this integral becomes 2x u to the minus 1 dx by du. We don't have dx by du right now, but we do have u in terms of x. And so u differentiated with respect to x is differential of this side, 2x. We also know that from chain rule that dx by du is 1 over du by dx. We have du by dx, so dx by du is 1 over 2x. If we put that back into our integral here, we have the integral of 2x u to the minus 1 times 1 over 2x du. Let me just move this next part down. So, what we're now going to do is we're going to spot that they've got a 2x on the top and a 2x on the bottom, so they cancel. So I'm integrating u to the minus 1 du. And so we have converted this from something that we didn't know how to integrate immediately into something that we did know how to integrate immediately. U to the minus 1 is one of your known integrals. When you're integrating with respect to u, it becomes ln u. So our integral, but I should probably call this I from the start. Our integral is ln u plus c. But we don't actually want it in terms of u, because the question was about x's. So it is putting that back in. We have ln x squared minus 3 plus c. There we go, we have integrated it. What you should now notice is that we have just got the ln of this x squared minus 3. And if we were to differentiate this, we would just, when we differentiate it, it would become 1 over x squared minus 3, and then we would times by the differential of x squared minus 3, which is 2x. And so, what the reverse chain rule allows us to do is when we see the integral of 2x over x squared minus 3 dx, we spot that it is in the form f dash of x over f of x to the n, and it's actually in the form f dash of x over f of x, because the n is 1. And whenever it's in that form, it becomes ln of fx plus c, or in other words, it becomes ln x squared minus 3 plus c. So what I'm saying is that you don't need to do all of this working to actually get to it, and that's what the concept of the reverse chain rule is. It is a simple, quick spot of how to solve it. But rather than just showing you that, I wanted to teach you why and how we do it. So this is the proper method here of how we solve this, and actually we're going to see that method come up again later. But if you can see it in a question, you are allowed to show something like that as your workings. Okay, I'm moving on to the next question now. So for this next question, we are again going to have to, let me just move this way. We are going to integrate sine x over 2 cos x minus 5. Again, I'm going to do it properly. I'm going to call u 2 cos x minus 5. So I've got the integral of 3 sine x all over u. I want to change it to u, so we're going to use that dx by du from our chain rule. Dx is dx by du, and so we define dx by du. Du by dx is minus 2 sine x, and so dx by du is minus 1 over 2 sine x. Putting that in, we are integrating 3 sine x over u times minus 1 over 2 sine x du. Again, sine x is cancelled, and we've got minus 3 over 2 u to the minus 1 integrated with respect to u. Now, minus 3 over 2 is just a number, so we can simply take it out the front. Minus 3 over 2 times the integral of u to the minus 1 du. That is again simply ln minus 3 over 2 ln u plus c. Again, we have to go back and find out what u was. U was 2 cos x minus 5. So this is minus 3 over 2 ln of 2 cos x minus 5 plus c. Again, we could have, instead, to integrate this, and we had the integral of 3 sine x over 2 cos 2x minus 5 dx, we could have seen that sine x was the differential of cos x, and therefore we can use our reverse chain rule here. We could have therefore realized that we have the integral, and this time it's not exactly the same. It has some constant k times f dash of x over, again, it's just f of x dx, and in this case what we will know is that's going to become ln f of x plus c, and we're going to have to take into account our constant here. Now, the differential of cos 2x is minus 2 sine. This is a 3, and so we get minus 3 over 2. And that step can sometimes cause people problems, so if you're ever getting stuck, again, we can use what we've done here in green as a proper, full, worked-through solution. Okay, our final problem, I have lost it. Let me just grab it again from up here. Our final problem, problem C, is slightly stranger, and what we're going to have to use here is we're going to have to use our trig rules, which we've now learned how to deal with as well. If you haven't done that already, you want to go back and do learning how to do integration using trig from one of my previous videos. So I'm going to say that u equals 2 plus tan x. So I've now got the integral of sec squared x over u squared. This is slightly different because it's u squared dx by du, because I'm changing everything in terms of u. I want u's. So again, integrating with respect to x is the same as doing dx by du by chain rule. Du by dx is differentiate this. 2 goes to 0. Tan differentiates to sec squared. If you don't know that, you're going to want to have another go at your differentiation tricks, because you need to be spotting that very quickly. So that is sec squared x. You might be tempted at this point to start talking about this in terms of cos, but because this is in terms of sec, I wouldn't. I'd leave it alone. We get dx by du is 1 over sec squared x. Substituting that in, we have the integral of sec squared x over u squared times 1 over sec squared x du. Again, these cancel nicely. We're asked to integrate u to the minus 2 du. When we integrate, we increase the power, then divide. So this is minus u to the minus 1 plus c. So it's minus 1 over 2 plus tan x plus c. And again, using the reverse chain rule, we can spot that 2 plus tan x, the differential of 2 plus tan x is sec squared, because tan differentiates to sec squared, and therefore you could integrate this as if it were just a x to the minus 2 here, because we are in the form integral of f dash of x over f of x squared. We are directly in that form with no k's, so that is going to integrate to 1 over f of x, because x to the minus 2 integrated, divided by minus 1 plus c, and so that is just minus 1 over 2 plus tan x plus c, which is unsurprisingly what we got before. So, reverse chain rule is a very quick trick to solve these integrals directly. It actually uses something called integration by substitution, which you will find later on my channel, labeled as such. Okay. Please put any comments in the videos if you have any questions. Thank you very much. Bye-bye.